Okay, on the domain and range. Shh. So on the first one, okay, don't let me interrupt your discussions here. Domain and range. So domain is left to right. So the left is a -4, and it gets a bracket because there's no open circle. And it goes to infinity. Bottom to top. The bottom is a -infinity, and the top is a positive infinity. Okay, so the next one, if you don't draw on the asymptotes, you get it wrong. And so you start on this side, it's a -infinity, and you go all the way until you hit the asymptote, which is a 0. And you have to have the u between it, and then 0 to infinity. At the zeros, both parentheses, because it's at the asymptote, and you can't touch an asymptote, so that is a parenthesis. Bottom to top is the same thing. We have to stop at the asymptote. Bottom to 0, 0 to infinity. So the last one, left to right, it is an open circle here, so this gets a parenthesis, and the 5 gets a bracket. And then bottom to top, it's -4 to 0. Okay, give me a thumbs up if you got those right. Okay, do the next two. Okay, so here's the next two. So first of all, I want to find a to -6. So I do a to -6, and I wrote all this out. And then I came up with the numbers, and then I got an answer. If yours doesn't look like this, you're going to, like, if you would have made an adding error, you would only lose a little bit of points. If you don't write this out, I can't tell what you're doing. Also, how many people got this for an answer? If you did not square the x squared, you didn't get this for an answer. You got -36 or something. Okay, so when I square this, 4 times 4 gives me 16. X times x gives me x squared, and I still have the negative there. And I can't combine these because this is squared and that isn't. Okay, do the next two. And they have to have parentheses. If they're not parentheses, they're wrong because I don't know what they are then. So it's a point, -3, 0, 0, 3. Okay? So then to find the zeros and the y-intercept. So first of all, the y-intercept, you put a 0 in, and we get a y-intercept. And I got 0, -5. Then you have to set this equal to 0, and we factor. So 2 times -5 gives me -10 and the 9. And when I factor, I get 10 and -1. And that has a leading coefficient of 2, and this one reduces. So I end up with x plus 5. Yes. Where? Because it's here. The leading coefficient is here, so you have to have it in both. And because I have the 2x plus 10, I can reduce this one. And to find the zeros, you set each of those equal to 0. So the x plus 5 sets equal to 0, and the 2x minus 1 sets equal to 0. And when I subtract the 5, I get -5. I add the 1 and divide by 2, I get 1/2. And it asks you to write it as a 0. When you write it as a 0, this is how you write it to get credit. Okay, I want you to do the next page now, number 8 and 9. And on number 8, where it says the critical points, I'm looking for the relative max and the relative min, the absolute max, the absolute min, or the point of inflection. Those are the points I'm looking for. Okay, so we had an absolute minimum here. I have a relative minimum here. And this is a relative maximum. Why is it not a relative? Why is it not an absolute maximum? We've got the infinities, okay? And there was no point of inflection on here, correct? All right. So then it asked for the increasing and decreasing intervals. So we always start on the left-hand side. And if I put my finger here, it's decreasing. So it's decreasing from negative infinity, and I know the number is off, right? I just put it as -1. Okay, I know it's off. So negative infinity to -1. But then what happens? So it increases from -1 to 1, and then it goes back down from 1 to 3, and from 3 to infinity it increases. We always use parentheses on these. Yeah. Okay, it's in your notes. Absolute is the absolute highest, and relative is not. Okay. So, I had 3 kinds of discontinuity. 3. I had jump right here, and you have to name where it is. It's at x equals -1. There's an asymptote here at x equals 2. And I have removable at x equals 4. So the discontinuity uses vertical. It always uses the x equals. And you have to name all of them when I ask on the test. X equals 2, yes. Okay. Shh. Number 10. So the discontinuities are the x equal. For the end behavior, you have to draw in the horizontal asymptote. You have to draw in the horizontal asymptote. So as x goes to infinity, what happens to the y? And it goes to infinity. But as x goes to negative infinity, what's happening to the y's? Goes to -5 because that's where the asymptote is. So jump gets the x equal, and the end behavior gets the y's. And it gets the horizontal asymptotes. So how do I decide if something is symmetric to the x, y, or origin? What do I test for the x-axis? You change the -y. If I change the y, if I want to test the y, -x. What about the origin? Both. And when you put the -x or the -y or both, you have to end up with the original function. And in this one, it looks to me like this is around the x-axis, which means I'm testing -y. And when I put -y in here, I get y squared minus x equals 4. That matches, so it's symmetric around the x-axis. What about the last one? And so what do I have to do to test if it's even? -x. What if I'm testing if it's odd? What do I put in? They're both -x. So when I put the -x in here, it becomes +x. This is the same, and this is the same. So if none of them changed, that's even. What if all of them change? Odd. What if just one of them changes? Neither.